record on this computer. And I think I'm recording. There we go. Now I'm recording. Cool. So this is the final session. Thank you all for coming. I know it's only Nate, Kip Sykes, and I. But I'm just gonna we're talking about recursive functions and when to use them and when not to. So I figured I'd talk about kind of what recursive functions are. So I'm going to go to here. A recursive function fundamentally is a function that calls itself. So function test, then I can run test inside of it, and if I call test, it will then run. It will then. I'm not sharing anymore. Thank you, Kip. If I make a function called test, which then calls test, I will then have an infinite loop. Obviously, that's effectively the same thing as saying while true, and then do nothing. Okay. Effectively is the same thing, and notice how this isn't even available. So when to use a recursive function would be if I'm not freaking recording on my computer. God, stupid thing. For some reason, it just stops recording at random. I don't understand why. Okay, so a reason to use this recursive function would be if you have like an async function where like request, where you can have a number of max requests, and you want to say request n times n dot then request n or catch console.log stop. Okay, so basically now what is inside of this can be if n is larger than a certain amount, then it throws an error, which then reaches this catch function. Otherwise, it will keep requesting the same function, doing the same function over and over again. And the time to use that is just if a function that you need to call over and over and over again, and you don't want to do like a for loop or something, this would be kind of how you do it. This would be a function that you want to call, and that would be the quote-unquote for loop that you are doing, but it's all asynchronous. And you can make this async, and it will still work properly. So, Nate, if you were going to turn your function that you are currently working on, into this type of loop, and so doing that asynchronous request in the loop, how would you do it? You want to show me how you would change your code?
I legit just changed it to using the await system, so I'm just gonna really quick commit that to GitHub.
Well, you can copy and paste and do the same thing on a different thing.
Yeah, I guess that works as well.
Yeah.
But like that way I can discard the change in GitHub so I can get back to my older
Oh, that's
code.
fair. Sure. I mean, both ways are completely valid.
Undo commit.
It doesn't matter. Just
I think undoing the commit. Wait, no, I just makes it so I didn't commit that.
I honestly don't know what you're doing.
The changes. Revert changes in commit. There you go. So now it's back to my other code. Like before I fixed all the dot.
Oh, right. Stuff. Okay.
So here's what I had: is I got the Axios.get Steam powered stuff to figure out whether I actually share or it's up here. First, I figure out if your profile is private or not.
Could you just kind of talk about what is this app.get? What are you trying to do?
So basically, when you go to my website and you go to user games / your Steam ID, it will tell you how much money you spent on games in Steam.
Okay.
So in order to do that, first I wanted to make sure that like if your profile is hidden, it doesn't just throw an error and not show anything. So I used this method to get your user data and then tested whether your visibility state is true or false. For
Okay.
some reason, they use 1 or 3 for true and false because they're strange.
That
I don't know
is
why they wrote it like
that is
that.
strange. Okay.
And then after that, you actually have to grab what games they own. So then you put in that with your API key and then the user person. And then it returns games. And then you go through each game. Then you use a second API, which finds the prices of the games because Steam's API doesn't actually tell you. So you have to
Mhm.
use 2 APIs. Then this one, when you give it the game's name, it searches through its database and then tells you what the game's name is in its database because it's really weirdly designed. So you have to actually do 2 different requests in order to get it. Because you have to request it to get the plain text version of it, and then you have to search through the database with that plain text version of it because they designed it really poorly. So like if I put Brawlhalla into here, it returns Brawlhalla but lowercase, and then you have to put Brawlhalla into here lowercase, or else it will break
So
for
wait,
some
where's
reason.
um game.name is what at this moment? Where your
Uh,
cursor just was. At line 49, game.name is what?
so I did a recursive through the
That's not
games list,
recursive.
or
That's
not a recursive,
iterative.
yeah, a iterative iteration through these. It's confusing because like sometimes you iterate through something by recursing. Yeah, it's
Yeah.
so you take the list of games which is stored here because you go data then response then the games.
Mm-hmm.
So I did poor variable naming, so this is the same as that. So then that gives you the game. It's just a plain text of what the game's name is in Steam. Then you use that to get what the name is inside the API.
And so, what is game data?
That's the return value over here. So this
So you
is
said something about like, your the what the thing returns is itself, but in lowercase. Is that
yeah
what you were
that's what
saying?
game data basically is. So if I'm just gonna go console.log game. If you go console.log game data, it just shows like a dictionary that has like a couple things, including the lowercase name and then like some random other stuff that isn't very useful, like whether it successfully found the thing you're looking for.
So game data plain
Yeah, that
is
gives you the lowercase name or the simplified name.
so
And
why
then,
don't oh it's not just lowercase, it's like a
yeah, for example, inside one game, they changed the 2, which was a 2, into 2 I's for some reason. I don't know why they
so
did it like that.
it's not like a consistent
No,
um
I don't know what they're doing exactly.
alteration.
There might be
Hmm,
some
that's
algorithm
annoying.
behind it, but I don't know what it is. It seems fairly random. And they also, I think, might add
Hey,
spaces here or there.
chaotic. It's
Not
chaotic.
not
Random.
necessarily chaotic, because
They
there's
have some sort of system, but you just don't know what it is.
yeah.
Wouldn't that be chaotic?
Well, chaotic is more like if you have like, for example, like a fractal. If you go across the line at certain points, it like very close together. If you just barely change something, it changes massively. Whereas like if you put in 2 incorrect values and then change one character, it's not gonna change the return value very often. So I'd say it isn't
Okay, I
that
see what you're
chaotic
saying.
because like 90% of the
Chaotic
time,
systems and random system, like that's one use of the term chaotic.
yeah,
Another use of the term chaotic is
yeah,
has more to do with you don't know if you
yeah,
basically if you knew every
yeah,
single variable, you can guess the outcome.
yeah,
And in this instance, a fractal or a double pendulum, if you knew every single state, you
yeah.
can't,
You wouldn't,
to the infinite degree, you can guess the outcome.
which
And
is why
that's the concept of this.
only quantum particles actually are random because everything else can be predicted hypothetically. But quantum particles have the uncertainty principle, so they're actually random. It's kind of interesting.
Hmm. I
Uh,
love talking about chaotic versus random. It's good stuff.
it's pretty interesting.
So if you were going to turn this into a recursive function, oh, actually, I
So
don't think you can.
wait, I
Oh
think
no, you can. You have a four.
over here I can go. Yeah. So instead of using this 4, I should store this in a variable at least. I'm very good at variable naming, so I'm going to call it games array. Not very. It's a bit confusing, but I'll just leave it
You
at
can
that.
also
Rename it later.
deconstruct games.data.response.
Wait, what do you mean? Oh, just rename it?
No.
Okay.
So you can say let games in double brackets equal data.response, games.data.response.
Hmm.
And it'll do the same thing.
Really?
Yes.
Weird syntax.
I actually really like it. It has less you just write less, basically.
That's fair. Though because of this inside of that, that is a bit weird because I'm pulling it from itself.
Yeah, it's called
Yeah.
deconstructing.
I think this matches up with that. I'm not quite sure. So then we'd go
Now,
here. I don't know if it does. Yeah, this is indented one more time, but I think that's. Oh yeah, it's because of that.
that's right.
Yeah, okay. So then over here, I think it would be after this. Then you go.
You need to make a function.
Yeah.
Yeah,
Or well, I was just gonna do axios.get the next thing in line. Oh wait, no, you can't do that. Yeah, you can't.
You have to have a separate function.
So what?
You also just deleted a
function
bracket that you shouldn't have.
equal.
No, you have to say you can say const get game data. So
Okay.
change line 49. Also, hey, on line 61, I'm sorry, line 60, make sure you have a closed bracket right there.
Oh yeah.
Yeah. So on line 50 or 49, the what you're doing. So say hold on, hold your horses. Hold. Okay, go back, delete function. Okay, const get data or get game data.
Actually, it's getting its cost. So I'll just
Or whatever. Okay, equals. Yep.
Oh, it
Nope.
actually has to be name.
Name, and then there you do the function thing. And now you do that.
Yeah. It's weird because the indentation isn't really.
No, I
It just looks
understand.
terrible.
That's actually the right way to do it.
Yeah,
Okay.
but the way it's indented still is. I feel like it shouldn't be that way, even if it is.
I understand. It gets easier to understand kind of what's going on. All right.
So
Now.
this should just be called name, and then
Mhm.
where else do I use? Oh,
And
it's down
then
here.
now in there you have like game of games of that thing at the bottom. So
Here?
yeah.
Here.
So
Oh, this is a
get rid
different
of.
thing.
Hold on. You
Oh
can do
yeah,
the same
okay.
thing. Get rid of .data.response.games. Up,
Where is that?
down, line 72.
Oh,
Oh wait, you have named games twice, actually. So go up to line 46. Okay, and at the end of that then, so you have a dot then, hit F2 right there. Okay, and now change that to like game info.
what? My dog
Game
just barked.
info. Game info. Hit enter. Okay. So now game info has all been changed. So now
Does
you're
this still work?
yes, it will still
Okay,
work.
okay.
Just you had games named twice, right?
Yeah.
So now go down to line 72. And now get rid of .data.response.games. Or yeah, get rid of all of that stuff. Just get rid of everything except for games. Of games. Yep.
Okay, yeah.
Now you can run that function. Okay. And now after or right before game string, so put on line 71. Nope, don't do that.
Yeah, I just realized I had a separate thing that I forgot to do or deleted somehow.
Get
It was
game
just
cost. And
then
you don't want to put name. No.
yeah. Well, I was
No.
gonna do that
Nope.
type thing.
Nope.
Really?
Put 0. Okay.
Oh, okay.
Now in name, click, make that N. Don't do
Name
F2
ID.
or
Oh.
just N or I number.
I'm
index.
gonna do I for index.
Okay.
Yeah.
Now, nope, don't do that. Don't do that. Now make another variable on line, right after line 49, called name.
Names. I was gonna do names, but yeah, and then cycle through it easier. Oh wait,
Why
no,
are you
games already
cycling
has
through?
that. I'm stupid. Yeah, I forgot about that. So
Name equal games.
I dot name.
I. Nope. Oh, yeah, you can get rid of the dot name
Really?
and deconstruct.
Oh, yeah. Okay, that's.
Double click on name, or that works too.
Yeah. Also, how does deconstruction work? Is it just
You're taking name out of games I.
okay?
That's how. Just think about it like that.
Cool. And
Okay.
then it keeps the same name as.
Yep.
Saying keeps the same name is probably the worst.
And you can also change the variable name by doing name : game name or something like that if you want to change the variable name.
Yeah.
All right. So now on then on the bottom then, so you have if, cost object, and all that
Oh
stuff.
yeah, and then I have this one again. Yeah.
Right. When you want to call the next function, call the next one, do get game cost n plus 1 or I plus 1. Yeah.
How
Or
does it work?
I would do I plus 1.
Really? Okay. Oh yeah. Because yeah. Okay.
Because you're not changing a global I, you're changing a single I. Okay. So now you're going to have an infinite loop. It's just going to keep requesting names, keep requesting names. I wouldn't put that in a try catch.
I guess yeah. You could also do it here. I don't know which.
No. Right on. Hold on. Line right after line 49. Add a single line. Okay. Now you're going to say if I is equal to I2 equals games. Whoa.
I don't know what that. Yeah. Games.
It does that. Games.length. Return. And you don't need that in brackets.
Oh really? You can just go.
Yeah. Return.
Isn't there also some weird if syntax with just like a question mark?
Yep. But that's for assigning a variable.
Oh, okay.
Now, this will work. And it won't have an infinite loop.
Okay. And also, I forgot to add something here. Or actually, no, I just deleted something when I was undoing it because this actually has to have a space.
And instead of concat, you can say game string equals game name plus equals, or sorry, game string plus equals game name.
That's like really convenient.
Plus, comma.
Oh yeah. Oh, yeah. Okay. So actually, also add a comma at the end, but that's not really a big deal.
And
My
then,
dog is like screaming very loudly.
If you want to, well, wait, what are you trying to do with that? Are you trying to just join all game strings together?
And then we'll make it readable as well.
So, game.name,
I can show you the end result as well.
do this as a, oh wait, no, you can't do that. That's fine. That'll be fine. You're gonna also get rid of the brackets for the for loop and put it on the same line.
Really?
Yep.
That is incredibly convenient. I did not realize you could do that.
Do a control delete. Right at the end of that, or do that too. Yeah.
Control.
Nope.
Okay.
Now use more semicolons. You are not using any semicolons right now, except for use semicolons, because once you start using that no bracket technique or thing, you will get in trouble for not using semicolons.
Okay.
Because JavaScript is run on a single line. It ignores all indentation. That's why you can have those indents and it doesn't matter.
I'm really used to Python.
Yeah, that's
Like,
that's a very.
I learned JavaScript just by translating Python over. So I really
Oh,
didn't know
I
that.
think you put. Yeah, you just put a. So see that dot then. Get rid of that semicolon right before the dot then,
Oh yeah, okay.
because
I
that
didn't know
stops
there
it.
as well. And then over here, I guess I'd put one, which is a bit weird.
Yep.
And if we're going into that, there's probably a couple other files I've.
Yeah, you don't need to worry about it. So now your function will work, or it should work. You should
Let's
test
see.
it and make sure.
Okay, now it returns a total of 0, so I screwed something up. Oh,
All right.
it's over here. This stuff shouldn't be. This stuff should be.
So you don't have a total. You're not. So what is your total variable? Yeah, you don't
Right
assign
here.
it. Total.
Oh, I put it up
That's
here.
your price, right?
Yeah,
And
that's the
plus
total
equals
cost.
price dot price old.
And that's just the older price of it. So that's like not a new copy of it, because for some reason this has 2 different types of prices. So I just took the higher one because it seems like it would be less sketchy.
Hold on a second. Is price old a number?
Yes, it is. Or it might be a string.
Is it a type number or is it a type string?
I think it's. Well, it's in a JSON, so it's probably a string.
Well, it'd probably be a number at that point. Well, no, don't do that. Just say, hold on. Get rid of that type of.
It was in a console.log anyway, so it doesn't really matter.
So you have total plus equals on the cost object, right? Just put a plus right before cost object. No space, just plus. That automatically turns it into a number. Okay, so now you are that is now a number. You are assuming that's a number. Great.
Okay.
Total equals 0. Hold on a second. Well, where else do you use total?
Just here, and here. Actually, I have a solution.
Wait.
You just put in T here, and then you just include total.
No, that'll work fine. It'll be
What?
fine. It'll be fine.
Okay.
No. That also won't work entirely. There are a couple other things. Look at the game data that you're pulling back.
Game data?
So go to the console.log, go to your console, go to your PowerShell, and you have that console.log game data, right?
I do?
Can you look at it? Yeah, right there.
Oh, I have to reload my page for it to actually log anything. Because of the way it's written.
Well, you already did it.
Oh, yeah, it's just a gigantic.
So it is working, and is it getting every single game?
I believe so. Yeah, it is. I should actually do game data.data because otherwise it's impossible to read what it's actually the actual import parts. So I'm gonna make that change. Because otherwise it just kind of shows a bunch of libraries that don't matter. Yeah, that's working.
So you are getting prices, you are getting all of that information. Yeah. Oh, hold on. Get out of there. Where's your res.json?
What do you mean?
Where are you sending your information? Here. There it is. Yeah. So you're sending that outside of the recursive function. That's why your total is 0.
Oh, yeah, okay.
So once you have the games.length return, put a bracket around return. And to put a bracket on without putting bracket, like making, hold on. Highlight return and the semicolon.
Oh, and the semicolon. Okay.
Okay, now shift bracket. Shift bracket. Okay, now put brackets around both. Opens and closes it.
What?
Now you have 2 brackets there. You open and closed around it. No, nope. You did it just fine. That's exactly what you want to do. Okay, now hit enter right before return. Actually, enter before.
Oh, just to turn it back into a.
Yep. Enter. Do another one.
Here?
Okay, yeah. Now above that, do the paste.
I could also just put return total, and then.
No, you can't.
Wait. Really? Even if I put a wait in front of this, like that, and put total.
Oh, no. You can do that, and you have to return it. There are a couple other things you can do, but this would probably be best, because this is easier to read, in my opinion. Because this is your close. You've closed it. You are done with the function. You're returning, turning nothing. Now, if you run it,
Let's see. Oh,
might
yeah, it
be an
does take a
infinite
while to
loop.
load because I have to access multiple APIs, and those are not the quickest, especially when it's like some random.
And that's why
button.
it was really fast the first time, because you had the res.json after everything.
Yeah. Also, it's hard to see whether my screen is actually loading because there's the UR screen sharing thing from Zoom. Oh, you can move that.
You can also do Control Alt Shift H.
Control Alt Shift H. Okay. I know there's a big press escape thing, but I guess that probably goes away.
That makes it come back.
Yeah.
So, is it
it's
now
still
an
loading.
infinite loop? I think it's an infinite loop right now.
I'm guessing it probably is, judging by the fact that it is.
Because you said
Oh,
return,
yeah.
return total, res.send for like game of games. Plus equals that. Hold on a second.
Might be angry that I'm doing this before that.
No, you're not. Nope. You actually want to do it before then, because if you return and then try to do it, then res.send will be unavailable.
That's fair.
It'll never reach that. So on line 56, hit enter, and then do a console.log.
Here?
Nope. Outside of that.
Oh, on the other side of. I'm already logging stuff, yeah.
And do it doesn't matter what you put in there, just to make sure that it's not running that.
Test
1, 2, 3.
Test 1, 2,
Good.
3. Test 1, 2, 3.
Good.
Test 1, 2, 3. Test 1,
This
2,
is
3.
working
Test.
as
And
expected.
it's done. I don't know what you can see when I'm screen sharing.
I can see. Total 79.97. Got it.
Oh, hey, it worked this time.
I don't know what was going on. It was just taking a while.
Oh, and also, I probably shouldn't have put a space before the comma because that doesn't look correct. I'm just gonna fix that real quick. There.
And then, if you want to get rid of the last space and comment, do like dot slice on the string, and get rid of the last two, and basically, game string dot slice.
Splice or splice?
Slice. Start at 0. Not -2, 0. Comma.
Oh, yeah,
Game
slice takes
string
the
dot
other thing. Okay.
game string dot length. -1.
I was thinking we'd do it the other way, where you just cut off the other
Nope,
part.
-2. -2. I lied. It's -2. Okay. Otherwise, you're just getting rid of the space. So now, once that finally loads, it'll show the comma. It'll get rid of that comma.
Yeah, I also have no clue how to actually send this to my actual dashboard because the way I'm fetching it is that, and I don't know how to actually pull it any other way.
So, do a post request.
Okay.
So change that from a get. Nope, not that. That. Change that to a post request. Put Steam ID inside of the body instead of the.
Wait, what?
So, all right. I'm going to show you how to do this.
Okay.
Okay. I showed it on one of my previous on like my web dev applied videos. But basically, let's go to my dashboard. So, I have a bunch of information on my dashboard. I'm going to sign in, and I'm going to submit. I'm signing in. All right. So now, I'm going to say library database. Okay. This is basically a library that I can access different pieces, and I can view the version history. I can check in, edit it, all of that information. Or I can go to library test or Boise State University band library. So to get this data, I need to request it from the server. Okay, and I have this function called search library. Okay, and it searches through this. So if I want to search through grand, it searches for grand after a half second of not typing, searches for grand, and it calls that function. Okay, and so in my library, in its static library.js. All right, so I have this function called search library. Okay, and I have I request from the server. This is my personal code that I made, and you can view it. You have it. You can view it here. Requests. You have this code. Request from server, and you have basically it sends a request, automatically pops on information if you're using a post request or anything, and other information. But basically, it requests from the server. Okay. So I'm going to go back to library. Okay, I'm searching for the library, and I'm searching. Here's my body. So a body is basically stuff that is information that you can embed into a request. All right, and in this request, I am embedding the library ID, the search value, the start, the end, which that's how this page 1 to 0, 1 to 1, and how I'm getting 22 results, right? The direction and the sort header. Oh, sorry, not the 22 results. It's a view 50 rows or 500 rows, that kind of thing, right? Hey, stop that. Okay. So, and then the sort header is that thing that I just clicked on where I can click composer or catalog number, right? So now this function is what I then use to populate the thing, and it's actually a really long function because of those that sort header API. It's kind of like a recursive function, basically. But if I go to my route, so I have a bunch of routes, and I'll show you how to use routes in a second. So I have library route. Where are you? Library route. Okay. So you can extend the index. I'm going to save this. I'm going to open index. Okay. You can extend your index by doing by using routers. Okay. So for routing, everything that has a /library, I'm going to use this function. So library route, and then is in here, this library. So I do const router, I deconstruct router from express, and then similar to index, how I do const express equals require express, I say app start initialize express. This does initialize router. Okay, and now similar to the app where I can go app.use, app.get, app.post. I then can use router.get, router.use, router.post. Okay, and then I just do module.exports equals router, and then it is available in library route. Okay, I then require my code from library route, and then I use it. Library route. So this basically just extends that code. Okay, so I send a post request, and it is search library or just search. Okay, and notice how I don't say library /library /search because I already have this is inside of the library router. So I don't. This would be like requesting /library /library search, which is stupid. So I'm not going to do that. Okay, so I'm just going to do /search. Okay, and then I get the search value, the start and direction sort header from the rec.body, which this was input by stupid thing. I got rid of the JS file, library.js. I put it in search value start and direction sort header. Search value start and direction sort header are both in the rec.body. So that's how I can pass in information, embed information into the rec.body. Now, in order to do that, you have to have some middleware, which is, I'm pretty sure I already gave it to you, but this app.use URL encoded and then the express JSON. Okay, so you have to use this exact middleware to do that. Otherwise the body will just be blank, which is just stupid. I hate it. that that's just how Express works. But they gave you that function to use, okay? And now I then run the function, the search function, and then I send res.json. I send all the rows, I send the headers, num pages, result length, search column, and header info, all in an object, which then gets parsed as a JSON and sent to the client. Where if I do F12, you can see header info, you can see headers, you can see num pages, you can see all the rows, right? And in there, you can utilize all of the data that's sent, okay? And it's all in the same format that you put on in here. Does this make sense, Nate?
Not really.
All right, so this library.js is sent on the is part of the client, and so I then can say request from server, or I can say fetch library search, and then I can say body do this. Body has to be an object, where like foo bar, okay?
Okay.
And then on the router, I then will have access. Router. I then will have access to foo. I then will have access to that. Okay.
Okay. Yeah.
And then I run my function. I do my whole thing, and that's the same thing that you were doing, right? That we were just trying to solve. And then I have this res.json. Okay. Similar to your, which is the same thing. Res.send. But you're sending an object instead of a like text string. Yeah. And so I then have a key value pair where I have the rows, the headers, the num pages, the result length, search column, header info, and all of that is available, as you can see in here. Rows, header info, headers, num pages, result length, and all of that information is here. Okay. And for every single request, I have on the request thing, I also have like some information. So I say post request, library search, time for post, library search, 283 milliseconds, total load time, basically 8 seconds, right? This is just for me to analyze how fast my everything is running, which once I actually deploy this, I will comment those out. But that is like, this is all just for me to view. Here's what's going on my thing. And it's quite a lot, but does that make sense, Nate?
Yeah. Wait, so what happens if you go to localhost 3000/library/search? Will it actually do
No,
search?
it won't do anything. Well, what I have trained it to do, what I've taught it to do, is to reroute to dashboard.
Oh, how did you do that?
On the server index, okay, basically on the app.get everything, okay, after all of the routers, after everything, basically I've this is after everything is done. If it ever makes it to here, then it runs this function, app.get this /star is called a wildcard, and then I have allowed links and allowed pages and all of that stuff that I get from the session, which I have created as an object that basically utilizes the cookie and stores information.
Yeah.
It's pretty cool. Okay. I then get the allowed links, and if no allowed links, or if the allowed links does not include rec.url.split, gets rid of all of that. Basically, if it does not include whatever you're allowed to have, it then runs the next function, okay, which that's what this res next means. It runs the next function, which brings it all the way down to here, app.get, if it includes the rec.url, which are these things, which are just things that I just don't want it to do. It runs the next function. Otherwise, it will redirect res.redirect to dashboard.
Okay.
Which I actually want this to redirect to about. So now, if I go to here, and I do blah, hit enter, and then it'll redirect me to about.
Okay. So what's the difference between a post and a get?
Post request, you have access to a body. Get request, you do not. So a get request is whatever you put in here. That will be a get request every single time. Where if you want to make something a post request, you have to actually like state, method, this is post. Okay, and you have to state that that is a post request. Okay, and then you have a dot then, and then a dot then. In order to do the fetch API, you have to say then res.json, then do whatever you want.
Okay.
JSON. Do your JSON stuff.
So yeah, can you only fetch post requests, or can you fetch whatever you want?
You can set your method to get. You can set your method to head. You can set it to whatever. I only use get and post. And anytime, here's the danger. Anytime you're running one of these fetch requests and you do a method get, this is where you need viewer engines. So basically, your browser, it's interesting, your browser stores those get requests on basically whatever comes back from the get request, every single get request, it stores in cache. And if you're not reloading, if you close and do Control-Shift-T, oh, because I have it reset. If you do close and then like restore, what the hell? Reopen, close tab. And you have a get request that was sent after you initialized or you did this URL and you came to this thing, it will load whatever came back from that get request, which can be really annoying because if you're running a get request and it's not your HTML that you want to display when you close out and come back and it's coming back from with holding cache, then it's not going to look great. It's going to be something else, right? Entirely. And so I only use post requests on the inside of the JavaScript. Every single method is post, every single time.
Okay.
Which I could probably just 100% of my methods are post, which inside of the JavaScript. So I could just probably just do where is it? Requests instead of get, make it post. There.
Oh, okay.
Also, async function request from server. This is deconstructing whatever I bring into it. This is where deconstructing is fantastic. I'm gonna kind of show you what I'm talking about. So actually, this is old stuff. Okay. So I'm gonna say let or async. Actually, it doesn't matter. Function test stuff console.log stuff.foo. Okay. I'm gonna say test. And I'm gonna bring in a function foo bar. All right. So now I'm gonna go to my terminal. Oops. And I run npm test. It brings me bar. Okay, that's pretty obvious. But what if I want to do not use stuff inside of there? This will also work. Okay, I'm deconstructing foo from there, and I'll also return bar both times. So this is where that deconstructing is really cool. We can go into a little bit of the syntax where you can say let object equal something. And you can say foo bar. You can also say greeting hello world. Okay, and then you can say const foo and then greeting hello equal object. Okay. Okay, and then I'm going to say console.log foo and console.log hello. And I get bar and hello world. So this is deconstructing greeting, but assigning it the variable hello. Okay, so that's deconstructing an object. You can also say let r equal a b. Okay, I can say const a, actually a b equal r. Console.log a b. AB. Okay, this is deconstructing an array where this has to be in order. The object doesn't have to be in order. Okay, so that is deconstructing arrays and objects, which is pretty cool. The next thing you can do, which I think is really awesome, is spread syntax. So I'm going to say let r equal a, b, c, d. Okay, I'm going to say let r2 equal array r. What do you think this is going to do?
Four arrays, each with one element in. Just based off the name of spread syntax. So like 4 arrays.
I haven't done spread syntax yet. What it actually does is it just takes the array and places it inside of another array.
Okay. Yeah, that's
Kind of
intuitive.
stupid.
I thought it would be unintuitive because, like.
I see what you're saying. Now, if I have 3 dots here,
Oh, okay.
this is spread syntax. And what it does is it copies the same array. Now I can say r2.shift, and I can say console.r, and it'll have 2 different things. So it'll have A, and it'll have all of that stuff. So I can shift, I can do this. Oops.
Yeah. I thought you just normally use .slice for that.
You can use .slice, but you have 4 functions. You have pop, push, shift, unshift, right? And that has to do with either end of the array. So pop and push will sequentially, it'll remove one or add one. So pop removes, push adds, okay? Unshift will add, shift will remove, okay? But notice how when I do r2.shift and I am consoling both r2 and r, I'm not changing r. I'm only changing r2. So spread syntax copies r.
Yeah, what I meant was instead of doing .r, you just do r.slice. Then you just take an entire copy of the array.
r.slice.
Yeah.
Yeah, that will also work. You can also do like json.parse, json.stringify r.
Oh, I guess yeah, that would work.
That will also work, right? But here's where it gets really cool. You can say let object equal foo bar. Actually, I'm going to say name is Nate. Team is not Taters.
Yeah.
Because you're not on Taters.
Yeah.
But class is Web Dev. But say you want to join Team Taters. You could say object.team equals Taters. Or you can say let new object equal ... object, comma, team, Taters. And I'm going to console.log object, console.log new object. Okay, notice how it changes team. It doesn't add a new team, it changes team. Okay, so, but the original one is still there. This is very useful for me when I have a library and I want to have version history. Okay, so on my, where is it? Library, I have so many JavaScript files. This is annoying. Okay, So I have, say I want to edit a piece. I have old data, and I get the old data, and I get the index of the new data, and I get a version, and I use the spread syntax on an object, and I do old data, okay? But I want to save the data, and so I get saved data, which is basically what they input, any new information they input. And so I take the old data, I spread it, and I take the saved data, I spread it, which then replaces whatever was saved onto the old data. And then I can save the data here. Does that make sense?
Yeah.
That's where spread syntax can be very useful. And it's cool stuff. Yeah. We kind of got a little bit off track, but
Yeah.
we're the only two people who are on this thing, and my dog is whining like freaking crazy. Summer, it's okay. Come here. So, do you have any questions about anything?
No, I don't think so.
All right. You want to show me anything else that you've done?
That's really been it. I haven't really done much more.
Okay.
So,
Do you have any questions about cybersecurity?
I don't know.
Because I have a couple of things to add on from the previous meeting.
Okay. I don't think I really have many. Yeah, I watched the video and then I don't think I have that many questions. So.
Are you scared? You should be.
Not that much, but
Okay, well then you're not. You weren't paying attention well enough. No, I'm kidding. So, kind of adding on to the previous one, we were a couple sessions ago. We were talking about a new programming language called Rust,
yeah.
and it's kind of a new development where you can run Rust on another machine, which is a C level. Rust is a C level programming language, a really low level programming language. You can Summer. You can run that language on another machine through the browser, and it will run at the same level as basically any system processing, right? Or at any other application that runs on a C-based level, which can be really cool, meaning that you can get rid of a bunch of delay, stuff can run really fast. But something that's really dangerous is then that application, that language can have access to many different files that it probably shouldn't, which means it can run ransomware really easily, which is obviously a problem, right? So that's one thing that is important. We didn't discuss, and you should be wary of, and you just need actually don't know what the what browsers are doing to protect against that, but I know that that will be a problem very soon, or it is already a problem, and they're working on fixing it right now. But that is a very scary issue where someone can embed code on their on their website and run it on your phone and destroy your phone just by you opening up a website. So don't go to websites you don't trust, basically. Even with ad blocker, even with all of those things, it won't protect you. Not everything will protect you. Yeah, I don't really have. There was one other thing, but I forgot it was. Kip, do you remember anything from that meeting that I forgot? I think I mentioned it afterward, but I forgot to write it down.
Yeah, I remember Rust. Excuse me, talking about Rust, but I can't remember the other thing.
I know there were two. It was bothering me.
Yeah. Well, while you're thinking about that, I'll just add in a little bit on the Android systems. So with the release of Android 12 to protect against some security flaws and stuff, when you, for example, if you use Android Studio to develop an Android app to run on Android devices, phones, tablets, etc., the data that app uses and stores is when you install an app, it creates its own file structure in the directory system on the device, and it only allows access to that folder. So that app theoretically does not have access to any other folders on the device, so that it can't go read pictures from your camera or other things.
Even, yeah. And isn't that called the virtual environment?
In a sense, it can be, but I know that there are ways around that, because the basic file explorer that comes with Android 12 kind of works that same way. You can't see some of the directories, but there are apps that people have deployed for File Explorer, if you will, that can see all of those directories. So I know that there's a workaround, from what they were trying to protect.
Right.
But that's something to just be aware of, like Taylor was mentioning, that any app, if it's coded properly, can break through that type of security that's in the operating system, and unless or until it gets patched. And I think that that's a security flaw that Rust is using to be able to operate and access other parts of the file structure because of some problems in the OS.
And I haven't researched too much about what Rust. I mean, I don't think it's just Rust, but Rust is very easy. It's an easier C-based language, and so a lot more people are learning how to use it. And I think that they're trying to implement it into websites and that kind of thing. I'd have to look into like what security protocols are that browser. I think it's partly on the browser. I think it's mostly on the browser, because the browser will have access to what the computer has given it access, right? And so it has its own that virtual environment, and the browser can hand it any information, hand your programming language any of that information. And so I think it's on the browser to protect your computer in that sense. And so making sure that it's only sending files from a specific directory. And at that point, this is beyond me. This is beyond my. This is all conjecture. This is beyond my level of programming knowledge. And I trust the people who are designing browsers who know way more than I do. I trust Google. I trust, Safari. That just tasted like vomit coming out of my mouth. But you know what I'm saying. Like, they have people who are better at the stuff than anyone else in the world working on this, and so I trust them to have our best interest at heart, because otherwise their stock will plummet and their product will go away. So they have a huge stake in this issue. They will lose a lot of money.
But to that one point, and you brought up an excellent thing about virtual machines. So I'd say that browsers and other apps are not truly a virtual environment. There is software that you can actually set up a virtual machine on your computer.
Anaconda is one of them. Yeah.
That is isolated from the rest of your system. So if you wanted, in effect, to go out browsing the web and download and try a new game or some release of something, what you probably should do is set up a virtual machine and operate through that to the web. And that will keep it firewalled or contained separately from the operating system that you're running on the computer. So in effect, you are protecting or insulating yourself from anything, and that's just often in its own little virtual environment.
Mm-hmm. And I think browsers do operate on a virtual environment, because JavaScript, the client-side JavaScript, only has access to the DOM, to the and the browser, and all of that information that the browser holds, right? It can't access client-based JavaScript cannot access files on your computer, meaning that any variables that is any information that is sent to that programming language is only is sent by the browser. And I think is how it works. And so basically, I think it's on the browser to basically set up that own system, independent system. All right, Rust, you can operate here. That's it. Here are your variables. Here's what you get. We can eventually give you more if you absolutely need it, but we need to recognize what security what security problems that could arise due to us doing this, right?
Yeah,
So
and to that point though, your browser stores cookies on your machine. So it is writing something on the hard drive. So it does have access to your physical machine, whereas a true virtual machine is running only in memory and does not provide access to any hardware.
I see what you're saying. Yeah, because the browser only has access to the files that computer gives it, right?
Yeah,
Otherwise, it'd be
and so
malware,
it's
basically.
trying to put them what I would call a demilitarized zone, or something that it's in a presumably safe area on the hardware, whereas a virtual machine is all virtual. I mean, it does not permanently store anything.
Everything's in cache.
Yes, it's all in RAM.
Okay. Interesting. This is a cool discussion. I like talking about this. So I don't really have anything else for today in terms of review or in terms of displaying or showcasing our projects because, well, we only have Nate, and you already showcased what you wanted to showcase. The next thing on the docket for today, outside of those two things, was kind of optional, but I think would be an important thing to discuss and start diving into the future of the web development in Tators, and what we want to do. And so I think Nate, I kind of want to know what your relationship is with Tators. And if you want me to stop recording, I can. But Nate, what is your relationship with Tators?
Well, so last year I was friends with someone who now goes to TVMSC, and I also am friends with his sister. Then that friend goes to the Taters Robotics Club, and then his mom was interviewing for my school, which is really complicated. So she gave me a link to the class information, which is a bit strange. So I know someone who's in the Taters Robotics team. Then his mom invited me.
So Nate, would you be interested in joining
I might.
on the scouting aspect? Because the future of scouting is is changing. And I have been pushing for this change for, oh God, well, actually, better part of a year. And Kip, you've been pushing for this change for quite a while. A browser-based system would be so better. A browser-based system would be so much better. It's like, it's right, but it's so like no one really had the expertise to push for that until I started learning on my own, and now I'm like, shit, I should probably teach this. I should probably put my money where my mouth is, you know. And so I'm trying to push for the change of turning stuff from the Android Studio into more of a browser-based system, which is much more verbose. And not verbose. It gives much more. It's much more flexible. Yeah, I'm really excited for this change, and here's the thing: I can't do it by myself. We really need help on this, and so on this dashboard that we're creating, we want to display the information that we have collected from the other teams. Do you Nate? Do you know what FIRST is and how like FIRST robotics competition operates?
Not very well.
Okay,
I've
what
kind of
do you
picked stuff
know?
up just from being in these classes, but not much.
What do you know?
Generally, there's some sort of challenge, and you build a robot to meet that challenge. I think there's two different challenges within that. Then there's also some divisions. I think 4 quarters. That's mostly it.
Okay, so I'm gonna start from the basics then, because you've got actually like really good key points, but you've got some pretty big holes. Only because you haven't participated, which I'm not judging at all. So basically, um, there are about 6,000 teams in the world, 5,000, 6,000 teams in the world, and everyone's competing against each other on First Robotics Competition, FRC. Okay. In this, you are given a task on the first Saturday or second Saturday of the year, and you have 6 weeks to build a robot, which I think has been extended, but I'm not 100% sure. You have 6 weeks to build a robot, and before you bag it and tag it and ship it off to your region, or ship it off, quote unquote, to your regional. Um, and so in this challenge, you have to complete like a bunch of tasks, and some tasks could be like picking up a cube, setting it up on a balancing thing, and you're trying to when it's tilted in your favor, you are accumulating points, right? And if it's tilted away from you, the other team is accumulating points. And so your goal is to have as many cubes on that as possible, and as few cubes on that for your opponent, right? And then there's like an end game where you have to go in, and like in this specific game, you go up and hang. And if you have 2 robots hanging, then you get more points, right? And you get what's called an RP, which has to do with how you rank with all of the other robots at that regional. With most regionals are around 30 to 60 teams. Okay, and so you're competing with that. Once you have ranked, you then select your alliances. Okay, and alliances of 3. They all compete with each other, and the top 3 alliances who win this bracketed competition. So you have quarterfinals, finals, quarterfinals, semifinals, and finals. Whoever win that bracket competition then go on to the championship. Okay, and you can attend as many regionals as you want, get as many opportunities to win. Okay, when you get to the championship, it's basically you have 6 different regionals, all competing with each other, and whichever team comes out of those regionals, they're called divisions. They all compete in another bracket competition, and whoever wins that bracket competition wins the final championship. Okay, it's just this huge thing of it's a huge competition, starting with regionals, then going to divisions, then going to Einstein. Okay, you also have another thing called what is it called?
Well, there are districts, but when you get to the world championships, there are over 30,000 students that are competing, over 400 teams from all over the world.
Yeah, it's crazy. It's huge. And it just gets harder and harder. And so your goal as a robotics team, especially one where you want to be in the lead, you need to know everything there is to know about every other team you are competing with and against, right? And in order to do that, you have to scout and accumulate data. And so for every single match, there's about 90, no, how many matches are there in a regional? Usually around 60 matches in a regional. And each match has 6 teams, 2 alliances, okay? So 3 robots per alliance, okay? And for the qualifications, those are all sorted randomly, okay? And so you have 6 scouters, 6 people scouting on your team, who are assigned a single robot, right? And they learn everything that they possibly can about that robot and put it on their tablet, which then is sent to what we want to be a server, okay? And that server will then send API requests to what Kip is building right now, a database server, an SQL server, which then gets those requests, populates the data in the database, which then is accessible to another server. And that's, or maybe the same server, doesn't matter. And that server will feed the dashboard, which then you can access all of the information by searching a certain team, searching event, searching whatever. You get all of Tator's information on this dashboard, and that dashboard will be accessible by the drive team, and they will have just on their fingertips, on their phone, immediately after we press submit, they will have all of this information on their phone like that. And that's our goal. That's the power of a browser-based system. Whereas if you do it like via flash drive. You then have to plug the flash drive into every single tablet, push the data, then you have to go into the computer, accumulate the data. I know this is worst case scenario, Kip. And then you take that flash drive, you run all the way over the stands, and you give the flash drive to them. They copy and paste the data, and then you grab the flash drive back, and you just do that over and over and over again. There's a wireless way to do it. That's the worst way to do it, but that basically is what we're trying to speed up, okay, and make that process automated, right? And so in order to do that, we need people who can code in a browser-based, who can code websites. And that's why we built this class, this web development class, and showcasing dashboards, learning how to build a dashboard. Because you learn Chart.js, you learn just fundamentals of JavaScript, you learn HTML, you learn very little CSS, but you kind of understand like selectors and stuff like that, and you learn logic, you learn all of these things. You then will learn like API requests and all of this stuff. And I recognize it was only like 11 weeks, which is not very long to learn all of this stuff. I've been doing this for about a year and a half. Even then, that's not that much time. I'm making a lot of mistakes. I could be better at this. But that's the kind of the fundamental idea of this whole class, is for us to build this dashboard. So the question is, Nate, would you be interested in building this, in helping this project?
I think I'd definitely be interested, especially because I have summer break now, so like that's a lot of free time on my hands, and I don't have any projects to use it for.
Kip, did you hear that? I think we have a scouter.
Yeah, and also I probably should learn SQL so I can do some data algorithm stuff.
SQL is really easy, honestly.
Okay.
It's very easy, and in all likelihood, if we set this whole thing up properly, you won't be doing any SQL. Yeah, all the SQL will be handled by the SQL server.
Yeah.
And so the idea is basically, remember that sending to Steam as an API? You could send to Kip's server, the SQL server. You could send API requests, put stuff in the body, and then that'll put stuff onto the database. And then you're going to have other requests that just, hey, I want to get information now. And so you could have like get requests and post requests if you want. Yeah. If that makes sense.
Yeah, but like in SQL, would you maybe need to do some sort of like, oh, so it's just in spreadsheet.
That's basically all on Kip. Okay. Honestly.
Yeah. So I mean, here's a real simple thing. I think I'm sharing my screen now.
You are.
Yeah, you are.
Yep.
As I stored a procedure in here to just go in. This is running inside of Excel, but I have a SQL server running on my laptop right now that has match data in it. And so I set up an SQL request. Let me see if I go over to the workbench. So this table here has got the match schedules, and like Taylor said, there are like 90 qualification matches and then the playoffs in this event. And so if I want to find all of the matches that just Team 21-22 is in, I could do that from a code here. And this would be the code that I'm running actually from Excel.
Well, aren't you calling it in Excel and it runs on the server?
Yeah, and so I come in and say, well, let me see, if I want to select 21-22, and I could select this from any event, any year. But right now I've just got certain data in there, Utah, West Valley. And when I place that call, I'm placing the request to the SQL server. And it's showing me what the data that it returned is. And now I can import that into Excel, which basically just repopulates that same table because that's where I had it highlighted. Similarly, if I wanted to get the entire match schedule, I could just go over, pop that, and it populates. So basically that's just sending a request to the SQL server and populating it in Excel. Similar request could be done through the browser and web server. So that's part of what I'm working on right now is trying to get that set up to run through a web browser, which is, I mean, it's no more difficult and stuff. So
basically, it all operates on that URL type of thing. It's just the only difference is this is operating through Excel's workflow, Excel's UI. This is just using URL UI.
So you can see right up here, my connection to the SQL server is going to an IP address and a port. And so it's basically the same to connect through a web browser interface.
That's really cool. I'm excited for what you can do with that. And the whole point of all of this is to automate it, right? And so you don't have to press import and then press the call, do all of that information. It just automates everything. And so the user, what Mark would do, the head mentor would do, would just open up his phone, press this event, or would automatically do this event because today, like you can do date.now and that's today's event. And it will automatically call today's event with information about the next match, and will just right there at his fingertips immediately.
Yeah.
All of the data you could possibly capture, or we do capture.
Is SQL just storing data, or does it also involve like
SQL
analysis?
SQL is a language just like every other language, except for it is it's basically meant as an interface to what's called a database. And a database is like an Excel spreadsheet. Well, not a spreadsheet. It's like Excel in that you have you can have those different sheets, right? And you can call those basically tables, and you can run SQL on those tables. Okay, so I have all of these tables. Okay, so say I want to log into an account, and I store all of my accounts on this accounts table. Okay, which contains first name, last name, email, all of this information. Okay, so say I want to log in, and that is on my account routes. Okay, I have this API request called sign in, and I go to account, sign in, and I go into here, blah 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 blah, all of that information. Yay, all of that. Here we are. Okay, so find account query. Okay, so I select all from accounts where username is equal to this or the email is equal to this. So I'm going into accounts. So I'm selecting everything from accounts, where the username, where is username? Username. There you go. Username or the email is equal to whatever I import. And this is just to avoid SQL injection, which is a really bad thing. Basically where it's equal to that, and then if there is no account, then basically it sends a failed message saying, hey, this doesn't work, and it should be a half a second, sorry. And else then the account is found, and then it calculates the derived key, which then pulls basically the salt and the key from the account, the salt and the key from that account, which is right here, the await database, the account, and the salt and key. And then it runs the rest of it, basically checking if what the user input is the same thing as the derived key, right?
Yeah.
But this is one place where you can use SQL. And there are many different uses for SQL. Like if I want to log into an institution, or where's an inner join statement? Oh, here's another SQL. Insert institutions, all of this information where the values are equal to this. Right? This is more SQL. Basically, it's just a way to interact with a database, and it reads almost like plain English, right? And so this is pretty clear that I am inserting into accounts and institutions, and I'm inserting account and institution, the values that and that, right? Or I'm inserting into institutions, name, ID, type, and you can read basically exactly as is. And here's an inner join statement. Basically, I'm combining accounts and institutions together, and I'm comparing. I'm using I'm pulling data from another table by accessing another from one table, accessing another table. It's a kind of cool thing. But basically, you can think about this as in a full spreadsheet. Actually, I'm going to do classes. Okay, you can see here's the information from one table. This is my classes table. So I have a class ID. I have an instructor which just connects to an account. And then I have like a price model, a title for that, and then a description. Okay, and all of that information is accessible through SQL, and it looks very much like just any other like spreadsheet, right? It looks like looks like it. What's it called? Excel. Ensembles. All right, I did that. Ensemble players. Here's that. All right, I do guests. Oh, I don't have guests. What's another one? Alerts. Oh, there's no alerts. Accounts and institutions. All right, here's all my institutions connecting with accounts. Does that make sense, Nate?
Yeah. Another question is like, if you had just raw data and then you wanted to derive certain other data from that raw data, would you be doing that in SQL or in one of the like JavaScript stages?
You can have different types of things. Like, say you want to count how many accounts there are, you can select count all from accounts where condition, right?
You can do calculations on different fields as well. And so that's something that we do a lot of post-processing on the data that we collect and create new data out of it. And so my long-term goal is to have the SQL data definitions do those calculations. Right now, they're all being done in Excel, but that would be a long-term goal.
But that's also really slow.
Yeah, so
Excel is very slow.
In Excel about 1 minute to post-process the data because I iterate through every second of the match and do probably 1,000 calculations on that 1 second's data.
And because Visual Basic is a really high-end language, it's not a low-level language, it's a high-level language, it takes a long time. Whereas if you did this on JavaScript and you did it correctly using like map functions and stuff, which do not operate on a high level, map and other array functions, they operate on a C-based level, which is why they're really fast. Instead of taking 1 minute, it could take 3 seconds, right? So this is another reason why we want a browser-based system.
Yeah, so would the scouting team just automatically input data from the API without actually doing anything straight to the server, or would they be doing stuff other than that?
Basically, they would gather data like, hey, they accrued this many points. They shot this many balls. And here's where they put them. And then they hit submit. That sends it to the server, which then takes that data, analyzes it, maybe does some calculations or whatever. But ultimately, at that point, it just wants to post the information and put it publicly. Okay.
But we also do pull from a different API that is the official scoring system, or basically the data coming out of the event to collaborate or validate a lot of our data. So there is reading from an external API automatically also.
Okay.
Which that would be really easy to do on the server. So like, oh, I'll wait for every single one of these requests. Once those requests have been submitted, then check with the Blue Alliance, await for that information. If there is a substantial difference, Not just like if it's like 1%, maybe 2%, it's like okay, fine, whatever. But if it's like a huge like 50 to 75%, fuck, that's bad. Pardon my language. That's bad. We then will send, oh, here's the outlier. Hey, we then will send like a request or an information saying, hey, you screwed up. You need to fix this. And that would be automated. We don't have to go in and analyze and be like, that doesn't make sense. The computer will do it itself, right?
Yeah,
and-
and so like right now, we have an automated procedure that there are 6 robots playing in a match. And if for some reason we miss one of the robot's data, because either the person collecting that data put the wrong robot number in or something, we're comparing it against that match schedule. And if we only have data on 5 robots, it flags it. Well, now we would automatically be able to alert instead of having to go manually check and see what's missing. It would pop up immediately after the match.
Probably wouldn't be immediate because I don't know how long the Blue Alliance takes, but it's a similar concept. Like it would.
Oh, we wouldn't.
Actually,
We
not
don't
hard.
check against the Blue Alliance. We know against the match schedule if we're missing the data. So that's as soon as.
Oh, I see what you're doing. Okay. So, yeah, it's a really cool concept that we just need time to build, and we are starting now. Right now. Because we want to have a basic version of this database, of this dashboard, viewable, out there, just available by anyone, by our team, out there, and by when is it actually basically by when school starts for me.
Yeah, first week in September.
Oh, okay.
Yeah, we don't have much time, but because you know JavaScript, you know client and server based JavaScript, you know how they interact, at least to a fundamental level. You could theoretically help build these dashboard pages.
Yeah, am I
What do you
allowed to
think?
join mid-year?
This isn't mid-year.
Oh, okay.
It's
never
actually,
mind.
what grade are you in?
9th going into 10th, I think. Wait.
Yeah, you are eligible. So I need you to reach out to Mark, but would you actually be interested in helping build this dashboard? Can I give you homework?
Probably, because I really do not have much to do over summer. So,
Okay. Well, what is your Discord?
it's really cringe because I came up with it when I was 9 years old, but it is. I have to find it. Oh, there it is. Charizard Extra EX, number 4633.
Charizard Extra. Yes.
EX,
Number
EX.
Extra EX.
Number 4633.
Didn't work. Okay.
Oh.
CHARZARD
I believe so.
EXTRA
Yeah.
EX
Yeah.
number 4633.
Yeah, like the pin.
Yeah, that didn't work. All right, I'm going to send you mine. Mine is being sent over the chat. There you go.
Okay.
Friend me on Discord, and we will be in touch on homework to be doing. What I need you to do, and anyone who is watching this video, what I need you to do is learn Chart.js. Okay, that's the main thing. Learn Chart.js. At least building line charts, build different charts that you want to build. Say, Nate, for you, you are comparing information, you are getting information, total information, or total price on all of the games. What if you made a bar chart for how many actually do 2 different charts. You have a bar chart comparing how much you spend on each game, and then do a timeline chart, a line chart of how much you spent per time. Yeah.
And actually, you can do a third chart, which is how much your games have changed in value over time.
Oh, that too. I didn't know that you had that information. Do that.
Yeah, because for some reason, one of the APIs just tells you whether you can pirate games or not, which is weird.
Lovely. That's great. Yikes. All right. So, do
Yeah,
that.
and once we get into actually building this dashboard, this will get back into, customer care, if you will, on the UI, on the user interface, as to what information do you want to see and how do you want to see it presented.
Mm-hmm.
So having the flexibility to model and present this information in multiple different ways is very valuable.
Yeah.
So that way you get a lot of practice. But it's like, oh, well, I didn't know if I put this on this axis as opposed to this other number on the other axis, it actually means something now.
Yeah. And you could also make it customizable, kind of like basically just a spreadsheet if you really want to make it.
If you want to do what?
You could also make the UI actually customizable and let them edit certain things.
Oh, if you want. Yeah. Yeah, learn that. I think
Okay.
Chart.js would be a great thing for you to learn in order to start this process, because we're going to be building a lot of charts.
Yeah.
The next thing will be another thing we'll be building is a whiteboard, where we'll be selecting different teams and making a whiteboard of strategy. So this team, you're going to do this. This team, you're going to do this. You're going to be able to erase, and you're going to have a bunch of tools around just a whiteboard.
Yeah.
And that uses a canvas, similar to what you were doing, that tracing thing.
So there's probably like libraries or APIs out there to automatically do that. I don't know if you really need to code that by yourself.
Probably, yeah.
Because like if I've made a library that basically does that, I don't think I feel like someone else would probably do that a little
If you've thought of it, it probably exists somewhere in code. We've talked about this API before. Yeah. You have to be careful about that. You just have to know kind of what it is you're doing and if it's customizable to what you want, because there are some things that we want to do that those APIs may not be able to do, right?
And you also have to include credit to every single one in some random file, like at the bottom of the page, which could get very large.
Yeah. So I'm going to leave you with this, Nate. This is actually something kind of cool. So I have a thing called sessions, and sessions basically stores, I have this object called current sessions, okay, and it's basically, this is on the server, browser-based server, browser-based storage, okay, and each session contains the session ID, which is the ID sent as a cookie, the latest activity, the role, the client IP address, the number of requests, the permissions they get, interacting as, the time array, which is just for something else, and then like something to just like delete the number of requests every minute, so then we can analyze like overload kind of thing, and user quota. Okay. So what I do with this is on a new session, I create, I take the session ID and I create a new session with a rec, and I have this thing called socket. Socket is basically the server becomes, basically socket sends like one request per second, or one request every half a second from the client to the server over and over and over again.
Yeah.
And it's basically in constant communication with the server. And when doing so, you can, or because of this, you can emit a request from one session and call functions on another session on their client. Okay.
Oh yeah.
So from my phone to my computer, I can send a thing and it will run a function on their browser, on that browser, right? Which where you would do this is in that kind of thing that we were talking about with, oh, hey, there's a problem with this data. We stored your data, we stored everything, but there's an outlier here. Fix it. Here's your information, but just fix it, kind of thing. And so another thing would be, that you should eventually learn, aside from Chart.js, but would be socket and understanding sessions. Yeah, that would be a really good thing for you to learn.
Yeah, I think I tried using sockets a while ago inside Python, so I have
Oh,
some
does
understanding.
Flask have that ability?
No, it wasn't Flask. It was just like Pygame. So.
Oh, okay. Well, those would be two really good things for you to learn. And Nate, if you have questions on, I mean, I need you to reach out to Mark Wibbles.
Okay.
And should we just give him his email? Kip?
That probably would be it.
That was Kip.
Oh, okay.
Yeah, well, maybe what we ought to do is, Nate, if you have your email and send that to Taylor.
Okay.
I have it.
Yeah, then what we can do is send an email introducing you to Mark, saying that you want to help us on this project. And you know, coming from us, then he knows who it's coming from, but that way it makes the connection or the contact with you.
Yeah.
Mm-hmm.
And then we can get you also included on the Discord server for the Tators.
Right. And then we can start working on the dashboard really easily. I'm really excited for this dashboard. I think we are capable of building it by then. And so basically after you learn Chart.js, after you learn Socket, we're just going to be starting and we're just going to be using old data from Kip from this year, and displaying various things on that dashboard. And I will be working on. There are a couple technical things that we need to work on to like have it published, but there's just going to be some really good stuff there. So I'm excited. Nate, do you have any questions about anything?
Not really. I don't think so.
Okay.
Yeah, and we will have some other people to help as well. So, but you seem to be fairly well along the learning curve. So I think you can definitely be a major contributor here. So looking forward to it.
Mm-hmm. Yeah, I'm excited, Nate. I'm excited to be working with you. I'm excited for what you can bring to the team. You've done a really good job on this stuff. From the get-go, you had a pretty good understanding of just like JavaScript and the various things you can do with it. You were able to easily understand what I was teaching when I was just kind of really. You were doing something with moths, if I remember correctly.
With what?
This was like moths. This was like a long time ago. This was like our second meeting.
I think it was like doing a print handler class.
That was like the fifth meeting. No,
Really?
yeah, there was a. Was it you? I thought it was you trying to display pictures of moths, and you were doing like a select.
That was me.
Okay, well, I must be mixing people up, but
Yeah.
just based on what we were talking about with async and await today, and actually you joking about the did you just have a realization?
What?
I thought I just heard you gasp.
Oh no, something fell on the floor. I think my dad dropped something.
Oh, okay. But based on what our interactions are, you have a good understanding of just web development at a fundamental level, and I think you'd be absolutely fantastic for working on this. So learn that and see if there's anything else you can learn out there. YouTube University is your friend. Trust me. That's how I learned where I am.
Yeah.
That's how I got to where I am. All right. Cool. I'm gonna stop recording. Thank you, Nate. And I'll see you next week.